So this is a continuation of fractional exponents. What I mean by fractional exponents is it's raised to the 1/4 power. When you have a power that is a fraction, remember the denominator always moves to the index of the square root, or not square root, I'm sorry, of the radical. So I'm going to rewrite this. I'm actually going to do this problem two ways. This is one of those spots where it's definitely up to you which one makes the most sense, but I'm going to do this two different ways and show you that it gives you the same answer. So I'm going to rewrite it in a radical form first. So then if I go and do the 4th root of 16x cubed. And then if we look at that, the 4th root of 16, well, if I want to find the 4th root of 16, then I can, or I need to go over here and do the factor tree, just like we've been doing. So 16, remember any combination works. I'm going to do 2 and 8. Then for the 8, I'm going to do 2 and 4, and then 2 and 2. Remember, those don't break down anymore, so those are my factors. Since this is to the 4th power, we have the 2 times 2 times 2 times 2. Well, I want to rewrite it to the 4th power so that it is easier to cancel. So I'm going to say 2 to the 4th power. And then we have x cubed. So it would just be x cubed. 4 doesn't go into 3, or if you look at it, I cannot rewrite x cubed as 4 and have any left over or go into it perfectly. So the only thing that cancels is the 4th root and the 4. I'm going to go ahead and write a second one there just so you can see it, and use whiteout. That is not underneath two radicals. It's just a single radical. And then the 4th root and to the 4th power cancel. So it'd be 2 to the 4 radical x cubed. And that would be my answer. That's as simplified as I can get. Now I told you I'm going to do it two ways. So if you look at what we have been doing, and remember you can multiply exponents. So if I have 16 to the 1st power and then x to the 3rd power, I can do 16. 1 times 1/4 is 1/4. And then I can do 3 times 1/4, which is 3/4. Okay, so when you have 16 to the 1/4 power, if I use a calculator, I can do 16 to the, remember to type a fraction into your calculator, you do top or numerator divided by the denominator. So I'm going to do 1 divided by 4. And notice what it gets me is 2. So if you look, that's what we got up here. Or you can still rewrite this as the 4th root and get your answer. So I'm going to say that it is 2, and then x to the 3/4. Since the fraction 3/4 does not simplify anymore, that just stays my answer. So I'm going to show you that 3/4 does not simplify. So remember, if you do numerator divided by denominator, so 3 divided by 4, it's going to give you a decimal. Remember, this math button will turn it into a fraction. So math, enter, because it says fraction, and then enter one more time, and it gives you the same fraction. So that means it's as simplified as it gets. So the final answer here is x to the 3/4. Depending on what the instructions say, whether it says to write it in radical form or exponential form, and sometimes it will say both. So this is our final answer. Notice the 3 is right there, the 4 is the index. So depending on which way the instructions tell you to write your answer, either in radical form or exponential form, on the next test that we're going to take, it has both. So you know how you can have a select all that apply question? It's actually going to say which are correct, or which of the following answers are correct or simplified, and you're going to have to do both. So on the assignment, I'm going to want you to do both. The instructions are going to say write it as a radical and as an exponent. So I'm going to expect both of these. X to the 3/4 and then 2 fourth root of x cubed. I don't necessarily have to work it both ways. Once I get to this answer, I can just rewrite it into radical form by saying 2, the denominator becomes the index, and then the 3 is the power. Same thing here. If I worked it this way and I needed to get exponential, I could just put it x3 divided by 4. Okay, now this next example is going to use what we've been learning all units. So we have x to the 6th, y, that's a terrible y, to the -2, divided by x to the -3rd, y, and all of it raised to the 1/3 power. So again, I'm going to work it both ways. First way I'm going to work it is using a radical. So the 3, remember, and actually I want an example like this, change that to a 2. So then we want to take the denominator and write it as the index. And then I'm going to keep all of that information. So x to the 6th power, y to the -2, divided by x to the -3rd, y. Now, don't forget that I changed that to a 2, so I need to raise the entire thing to the power of 2. And I'll show you how that works in a minute. Remember, we need to do what's underneath the radical first. And if you look at what's underneath the radical, we have negative exponents. So you need to change the negative exponents to positives. So this is a negative exponent. Remember, a negative exponent, if it's in the denominator, moves it to the numerator. So I'm going to have x cubed up here. And then if it's in the numerator, it's going to move it to the denominator. So I'm going to have y squared. So then I will have the 3rd root of x cubed, x to the 6th, divided by y squared, all of that squared. So I'm going to keep having to write that cube root and the 2 until I get everything simplified. Hopefully this next step will get it simplified though. So if we have x cubed and x to the 6th, so x cubed, x to the 6th, 3 plus 6 is 9, so I would do the cube root of x to the 9th divided by y and y squared. Remember there's an implied exponent of 1 there, so it'd actually be y cubed. And then again, we still have to write that squared until we get all the way done. I cannot do anything with any more simplifying on the inside, so I need to now deal with the cube root. Leave the squared till the very end. So then if we look at the cube root, remember just like when we were separating out to simplify like this, we can separate the radical out to cover the numerator, and we can separate it out to cover the denominator. Notice x to the 9th, oh, and don't forget your squared again. If we just talk about x to the 9th, the cube root of x to the 9th, we can rewrite x to the 9th as x cubed, x cubed, x cubed, because 9 goes into 3 times. So then again, I can do cube root. I wrote those really close together, I apologize. And then we have cube root of y cubed. Now when looking at that, cube root, cubed, cube root, cubed, cube root, cubed, all cancel. Same here. That is, if you don't remember that step, that is definitely something from another video that if you still need help on that, you either need to see myself or see the, go watch the video again. Or you need to ask for help. Sorry, I got tongue-tied. So then we have x times x times x, which is x cubed, divided by, in the denominator we have y. And then again, don't forget about the squared. So then if we have this 2 times, or to the second power, we have x cubed to the second power. Or if you have x cubed twice, you would have x to the 6th, because x cubed and x cubed would make x to the 6th. And then we have y, which would be divided by y squared. And that is your final answer. Okay, I'm going to have to flip over to do that problem again in the other way. And I personally think that when you're talking about fractions like this, it is definitely sometimes easier to just use this rule that I was talking about, where you multiply it in. Okay, I'm still going to simplify inside of the parentheses first, just so I don't have to multiply in as many times. So if I have x to the 6th divided by x to the negative 3rd, get rid of the negative exponent and move it to the top. Get rid of the negative exponent and move it to the denominator. So then we would have x cubed, x to the 6th divided by y squared, all raised to the 2/3 power. Simplify in the parentheses. We have x to the 3rd, x to the 6th. So that becomes x to the 9th. This is a 1, that's a 2, is y cubed. I hope I'm not going too fast. I hope, since we did that just a minute ago, that we're okay with how fast I went. Okay, now, when we do this, we're going to multiply the exponents. Remember, based on your rules, when you have a power to a power, you need to multiply the exponents. So if I do 9 times 2/3, this is definitely one of those times that you have to remember fractions, and this is why if you don't remember how to multiply fractions, you're going to end up needing to do these steps down here. So if we have 9 times 2/3, remember when you're multiplying fractions, if it's a whole number, put it over 1. 9 times 2 is 18, and 18 over 3, or 18 divided by 3, is 6. Another way you can think about it is 9 and 3 can reduce. 9 goes into 3. 3 goes into 9 3 times. 3 goes into 3 1 time. So 3 times 2 is also 6. Your calculator will also do it for you. If you do 9 times, make sure you put parentheses, 2/3, and that's 6. This is definitely a review of fractions. So 9 divided by 1 times 2/3. 9 times 2 is 18. 3 times 1 is 3. Multiply numerators, multiply the denominators, and then 18 divided by 3 is 6. So then we could rewrite x as x to the 6th power because of that. And use orange for the y just so that we can see the two different steps. So then we have 3 times this power, so 3 times 2/3, 3 over 1. 3 times 2 is 6. 3 times 1 is 3. 6 divided by 3 is 2. You could also do What color do I want? I want red. You could also do 3 and 3. 3 goes into 3 one time, 3 goes into 3 one time, it's 2. So then your final answer would be y squared because of, oh, I didn't use the same. I wanted to use orange. Sorry. Because of this 2 right there. So that is your final answer. Notice this one cannot be written in radicals because everything's simplified. So we have x to the 6th divided by y squared. If you don't know how to use fractions, this is the way I suggest. This way, if you know how to multiply fractions like that, then this is your answer. You can see that it excuse me. You can see that it was definitely a lot less writing. It was just more of you had to know what to do with the exponents.